Hey guys, if you're on, I'm just going to give people a couple minutes to get on and we will get started. Again, if you've just signed on, we're going to give people another minute or two to get on, and then we'll get started. And I'm sorry for the typing. I have to put the link on my teacher site. Okay, so throughout this, guys, if you have questions, feel free to either type them in the chat if you're signed into your YouTube account, or you can get them to me on the class code, which is right here on the screen right now. Check that out. We'll give people another minute or two, and we will get going once we get a couple people on here. And I will BRB. I need to get more hot water. Very important things happening here in the Dronda house. I'll be right back. All right, if you are on, hi. I just was grabbing more tea, which is why I was not in here. So we're going to get started in a minute or two. If you're in my class, just use Remind as a way to interact with me, or you can use the live stream chat on YouTube. Just need to be signed into your YouTube account. We are going to go through everything pretty much that'll be on your test, the major things. We're going to try to keep this to about 45 minutes. Try to respect your time. I know 9 o'clock is late. And then we will go from there. If you're not in my class and you'd still like to interact, you guys can use this class code and just send me messages on Remind that way. And we'll get started in a sec. Let's see if we get anybody else on here. Whew. We're going to go about if we get anybody else on here, and we're going to go through, again, all the major things for tomorrow's test, and we'll go from there. Okay, so we're going to get started. Hi, if you're on, send me questions at any time, whether it's stuff you preemptively know you have questions about or things that you see as we're doing them and they pop up and you have questions. Just send them to me. The whole goal of this is that I can answer your questions. So send them to me, send them to me, send them to me. I am also free tomorrow during 2-2, during 3-1, right before your class. So if you have lunch 2-2 or 3-1 and you want to come see me, you're more than welcome to do that then. So we're going to get started with some basics of trig. I'm going to tell you guys this. My major focus tonight is sine, cosine, tangent, right? SOHCAHTOA, and law of sines. Special right triangles are great, but they are not something that most of the time you couldn't do in another way. So not something I'm going to spend a huge amount of time on. But if you have questions on those, come see me about them tomorrow. So we're going to start with just basic trig stuff, and then we'll go from there, okay? So, I'm going to start with this. The acute angles of a right triangle, right? So this is my right angle here. From either of the acute angles, A or B, I know that I have an opposite and adjacent, right? And then the hypotenuse is always going to be across from the right angle. So if I start from A, I would say that CD here is, or CB, sorry, is opposite A. And AC is adjacent to A, right? And same thing, now let's say that I started from B. So I would say here that this is opposite B, and this is adjacent to B. And so it matters where we start from, right? It matters what angle we use to start from, but you're always going to have an opposite, an adjacent, and a hypotenuse in a right triangle. So the big ones that you need to know here, okay, the big ones that you need to know are sine, and remember sine of an angle is equal to the ratio of the opposite over the hypotenuse. Okay? Cosine of an angle, cos of an angle, is the ratio of the adjacent to the hypotenuse. And tangent of an angle, or tan of an angle, is the ratio of the opposite to the adjacent. So, opposite hypotenuse, opposite, or adjacent hypotenuse, opposite adjacent. We can remember that again, remember with SO, CA, and TOA. These only work with right triangles, but let's keep those in mind as we're doing these. So, finding sine, cos, and tangent of something here. So, I've got sine, cos, and tan. I'm going to start from angle P. So, starting at angle P, I'm going to first label what my sides are. So, that's the hypotenuse, 15 is the opposite, 8 is the adjacent, right? And so, the sine of P is going to be the opposite over the hypotenuse, which is 15 over 17. The cosine of P is the adjacent over hypotenuse, A over H, which is 8 over 17. And the tangent of P is the opposite over the adjacent, which would be the 15 over 8. So when I say just find the sine, cos, or tan, especially when I give you the triangle, that's all I want you to do. I just want you to give me what the ratios are. And again, throughout this, at any point, just send me questions. Any time you have a question, send it to me, okay? All right, so the next one says, find the sine, cosine, and tan of S for the first triangle and R for the second. Express each in a simplified fraction. So we want to find sine, cos, and tan for S. So from S, I'm going to go here. Sine of S is going to be the opposite over the hypotenuse, so 8 over 17. Cos of S is going to be the adjacent over the hypotenuse, 15 over 17. And tan of S is going to be the opposite over the adjacent, which would be 8 over 15. So make sure that you know how to do those. All right, next one. To find a missing side, you are going to use the sine, cos, or tan buttons on your calculator, okay? To find a missing angle, you are going to use the sine inverse, cos inverse, or tan inverse buttons on your calculator. So to find an angle, you're going to use the inverse, right? Angle inverse, think about it, they will start with vowels, so that's how I'm going to find that. So let's take a look at these. So on this first one, we're going to use the ratios to solve for our variable. So I want to solve for x on this one. So I see that I'm starting with angle 54. From 54, x is the opposite. 5 is the adjacent. So I see that I have O and A. So thinking about so, ka, and toa. O and A is toa, right? And so I'm going to use that. So I'm going to say tan of the angle equals, go in order, OA, OA, opposite, over hypotenuse. So cross multiply this, put that over 1. X times 1 is X. 5 times tan 54 is 5 tan 54. And you just plug that into your calculator. And let me check. My calculator had dead batteries last I looked. I'm going to double check. That one's dead. These are dead. Mr. G stole my other one. Okay. We're calculatorless for right now. That's okay. So you'd put that in your calculator. All right, the next one is this one. I want to find X. So, same idea here. I've got 27. From that, 5 is the opposite. X is the adjacent. So, tangent, again, because I have opposite and adjacent, of 27 equals 5 over X. Now, this one's slightly different, right? Slightly different. Look at your positions. Here you had X over 5. Here you have 5 over X. So, same idea. Put this over, cross multiply. So, I get 5 equals X times tangent of 27. To get X by itself, I'm going to divide both sides by tangent of 27. These cancel. So, X equals 5 divided by tan of 27, which again, you could just put into your calculator, which I do not have right now. Okay, last one on these. So let's say I want to find the measure of angle B, right? So I'm going to look at B as my theta or my X or whatever I want. And we are going to try to find the measure of that angle. So from this angle, I'm going to look at what information I know, which is that this is the opposite and this is the adjacent. I got a little tangent happy with this. That's okay. And so I'm going to say, well, that means tangent of theta equals the opposite over the adjacent. Now, whenever I'm solving for an angle, I'm going to use inverse tan. So the idea is that I'm taking tangent inverse of both sides. So here I get theta equals tan inverse of 2 over 3. So in your calculator, you would hit second tan and then 2 over 3, and that would give you what your angle is in degrees. Make sure that you're checking your mode. I'll remind you guys before your test, but make sure that you are in degree mode, right? Not radians. Okay, send questions as you have them. We are about 15 minutes in, so don't feel like you need to wait till the end. Just send them. All right, quickly with cofunctions, sine and cosine. So here, this is going to be something that you need to know. Cos of A will equal sine of B when the measure of angle A plus the measure of angle B equals 90, or when A and B are complementary, okay? So when A plus B equals 90. So let's look at why, right? So in this one, it says, which of these is always true? And I know, just from repetition of doing this problem, that the answer should be 4, that sine of A equals cos of B. But let's look at why, right? So first of all, this is 90, which means that A and B together also need to add up to be 90 because the angles in a triangle add up to be 180. So I know that A and B are complementary here. That's step 1. Part 2 is looking at this. From A, this would be opposite of A, right? And this would be the hypotenuse. Now, if I look from B instead, then I'm going to switch colors here. This would be adjacent to B, but that is still the hypotenuse, right? So if I find the sine of A, well, the opposite of A is CB. The hypotenuse is AB. If I find the cosine of B, the adjacent is CB. the opposite is, or the hypotenuse is AB. So notice these come out to be the same. And it's because when those two angles are complementary, the side that is opposite A is adjacent to B. They are the same side, right? They're both CB there. So that's why that happens. But again, it's one of those properties you want to remember. When cosine and sine are equal, it means your angles are complementary. Okay, next one. So if sine of 2x plus 20 is cos of 40, find x. Well, here I see that sine and cos are equal. So what I know is that the angles have to add up to be 90. So 2x plus 20 plus 40 should add up to be 90. So 2x plus 60 is 90, which gives me x equals 15. Now, I've seen people do it other ways. They know that if this angle is 40, that this one has to be 50. And so they do it that way, set that equal to 50. That's fine. You're doing the same thing. But ultimately, we know that if sine and cosine are equal, we want our angles to add up to be 90. Okay, no questions yet, so send them if you have them. We're going to talk very briefly about law of sine, and then we're going to do some word problems, and then if you guys have questions, that's all I have planned. So we are going to try to do as much as we can right now that you guys have questions about. So last thing is law of sine. So how do you find sides and angles if, for instance, you don't have a right triangle? And the big thing I want to know here is that sides and angles come in pairs, right? So let's say I say this is ABC. Angles are always capital letters. I can find the sides by looking opposite those angles. So if this is angle A, and I go opposite that, that will be side lowercase a. If this is angle B, this will be side lowercase b. And if this is angle C, this will be side lowercase c. So, the law of sines tells me this, that the ratio of the sine of an angle to the side across from it is the same between each of my sides of a triangle. And so what I'm always looking for here are pairs, right? I always want to look for pairs, and let me show you what I mean by that. So I'm going to do sine of A over A, sine of B over B, sine of C over C. And the big thing I want you guys to remember on this is that you only take sine of an angle. So these have to be your angles. Okay, you only take the sine of an angle. All right, so let's do some word problems. So the first one here says, during its approach to Earth, the space shuttle's glide angle changes. When the shuttle's altitude is 15.7, its horizontal distance to the runway is 59 miles. What is its glide angle? Round your answer to the nearest tenth. So let's look at this. When the shuttle's altitude is 15.7, altitude should make you think height, right? So altitude, I'm thinking about my shuttle, and that's 15.7 miles. Its horizontal distance to the runway is 59 miles. Okay, horizontal. So here's my shuttle, it's coming down. What is the glide angle? What's the angle that it's moving at? So I'm going to look at this as my unknown here. And you can use law of sine. You can use, actually law of sine wouldn't work super well here. You could do it, but it would take a lot of work. You can do law of sine, or you can just do SOHCAHTOA. So I'm going to start from this angle. From that, I have the opposite and the adjacent. So I'm going to say tangent of theta equals 15.7 over 59. And then from there, to find an angle, I'm going to use the inverse. So theta equals tangent inverse of 15.7 over 59. Right? Plug that into your calculator, and you have your answer. Okay, now this one says, when the space shuttle is 5 miles from the runway, its glide angle is 19 degrees. Find the shuttle's altitude at this point in its descent. So, now instead of being 59 miles, we are 5 miles from the runway, right? And its glide angle is 19 degrees. Find the shuttle's altitude, so that's what I want to know. So, looking at 19 here, I still have opposite and adjacent. I don't know why I have so many tangent problems here. But tangent of 19 would equal the opposite over the adjacent. Put this over 1. So I would get x equals 5 times tan of 19. And plug that in your calculator and you get your answer. Make sure you're putting units on your answer. This is miles, right? So just be careful with that. Okay, this one. During a flight, a hot air balloon is observed by two persons standing at A and B as illustrated. The angle of elevation from point A is 28. So from point A, it's 28. From point A is 1.8 miles from the balloon as measured along the ground. So to here, that's 1.8 miles. And I want to round to the nearest tenth. So its question for me is, what is the height? Oh my goodness, it's another tangent question. So from 28, I'm going to do tangent of 28 equals h over 1.8. Put this over 1, cross multiply, h equals 1.8 times tan of 28. And so that would be my height. And it says round to the nearest tenth, so I would do that in miles. Now, it says point B is 2.9 miles from point A. Find the elevation of point B. So, I know that this whole thing is 2.9. Right? I know that whole thing is 2.9. And so what I'm going to do here is figure out what this missing piece is. So if that's 1.8 and this is 2.9, that means that goes up by 1.1, right? So this is 1.1 miles. Subtract those. And I just figured out what h was. So here's what I'm going to do. Now I want to figure out this angle of elevation, right? So theta, I don't know how this happens. Tangent of theta will be h, which is what I got right here, over the adjacent, which is 1.1. So theta here is going to be tangent inverse of h over 1.1. And we found h above. Again, guys, my calculator is dead. I don't have it on me. So, or my charge one isn't on me. So I would plug in my value of h here. And that would give me my value of tangent. Not every question on the test is a tangent problem. Okay, this is the last one I have planned. I promise it is not a tangent problem. And after this, I want you guys to send me questions because otherwise I'm signing off. So send me any questions that you have. We're just going over big ideas tonight. Anything else, come see me tomorrow. And I've got my phone calculator so we can do some actual math on this. Okay, so find the height of the building to the nearest foot. This is what I want to know. My height is that. And anytime I see a picture like this, 3 things that come to mind. Number 1, find all your missing angles. Number 2, find the shared side. Number 3, solve for whatever you need to solve for. Okay, so let's start with this. I know this is 35 right here. I know this is 48. And I see here that these are a linear pair. Somebody just said, do you have the review packet with you? I do have it. If you have questions, send it to me. I can open it up and we can do any questions you have. Okay, so 48 is here. These are a linear pair, so I'm going to do 180 minus 48. So this is 132. To find this top angle up here, right up here, I know that this is 132 and this is 35. So together, those are 167, which means my top angle is 13. Now, this is a right angle. That's a right angle. I know that this is 48, so I need the complement of that. So 48, this would have to be 42. And so now at least I've got all my angles. I love that I see questions rolling in. Keep rolling in. We'll talk about the question you just sent in a second, Meg. So looking at this, now I've got all my angles. Check. Let's find the shared side. The shared side between my two triangles is going to be this side that goes right between them, right? I'm going to call that y. And let's think about how I would find that. So I've got two triangles here. I've got this right triangle. I'm just zooming in a little so you can see better. So I've got this right triangle right here. Notice I don't know any of those side lengths. So that's not super helpful. Then I've got this triangle out here. That one I know a side length of. I know this 150. So I'm going to use that to my advantage. And something I was working on with some people today was if this gets confusing for you, take this and break it up into two triangles, right? Actually physically break it up. So there's one and there's the other. On this one, I know this is 150, this is 132, this is 35, and that's 13. And I want y. On this one, I know that's y. I know that's 48, I know that's 42, and I know that's 90. If it helps you, break them up, okay? So on this one on the left, that's the one I have more info about, so I'm going to start with that. It's not a right triangle, so my only option here is law of sine. So I'm going to start with the 150 that I know. That is across from 13, so I'm going to do sine of 13, sine of the angle, over 150 equals, and now look at what we want to know. We want y, that's across from 35, so I'm going to do sine of 35 over y. So cross multiply these, y times sine 13 is 150 times sine 35. I'm going to divide both sides by sine 13. And so y equals, and I'm sorry, this is going to take a second because iPhone is all I have right now. But I'm going to do sine 150 sine, nope, clear, 35 sine times 150. All right, this is not going to be pretty because I have only this. This is 86.0364654526569, and I need to divide that by sine 13. So that should be 382.46749.144433376. Not rounding at all, right? So now I'm going to use that over here to solve for x. So, knowing that, I can use law of sine or I can use SOHCAHTOA. It doesn't matter to me. If you're going to use law of sine, it'd be sine of 90 over y is sine of 48 over x. You can also just do SOHCAHTOA. That's what I'm going to do. So from 48, I'm going to say, okay, this would be opposite and hypotenuse, not tangent. So sine of 48 equals x over y, plugging in that whole answer there, right? So I would do x is y times sine 48. So take this big number, plug it in there, and so x would equal, again, back to iPhone, it's not pretty, that number times, parentheses, sine 48, which should be 284.2287, blah, 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 blah. And it told me to the nearest foot. So that would be 284 feet. Okay, so I had a couple questions come in. The first question said, do I have the review packet? I already said, yes, please send me questions on the review packet. The second question said, will we get a word problem about sine of A equals cos of B? So if you can think of a specific one, send it to me. But the way that normally you'll see that asked is a couple of ways. Number one, you could see something like, I'm just trying to scroll back to find when we talked about it, like this, where they said, well, which of these is true? Okay, where you have sine of A equals cos of B and you're just choosing that from a list of answers. Number 2, you might get something like this, where you know that sine and cos are equal, and what you want to do is add those angles up and set the angles equal to 90. The other way that I've seen it asked in the past is they'll say like sine of theta equals radical 21 over 4, or sine of A, and they'll say what is cos of B? Right? Well, if you know sine of A equals cos of B, then that would be the same answer. So typically that's how I've seen it asked. If you have something specific you mean by word problems, send that to me, please, right now, and I can go over that. Anything else? This is it. I'm going to give you guys about 2 more minutes. I'll hang out here. What questions do you have? What comments, concerns, anything? All right, I see one question that just came in. So, for number 2 on the front page of the review packet, so let me pull that up really quick. So, review packet, again, you guys have that. That is something that we worked on. Sorry, I'm just trying to get it open. Lots of clicking here. I hope that your brackets are not as busted as mine right now if you're watching basketball, by the way, because it's really not pretty. Sorry, guys. I'm a little slow right now. All right. Meg, I'm 99% sure that's right. So Meg asked about number 2 on the front page. I'm just waiting for it to open. My internet is being a little slow. Any other questions while I'm waiting to answer Meg's? Anything else? For some reason, it won't load the OneDrive, which is where that file is. Meg, my computer isn't loading the OneDrive, so if you send me, can you send me a picture of it on Remind? Just take a picture with your phone, and I'll let you know. Anything else? Okay, I think you guys are going to do awesome tomorrow. I think it's a very fair test. I think just make sure you're drawing pictures. That would be my biggest concern. But otherwise, I really do think you guys are in good shape. I'm proud of you. Your last quizzes were really good, and I think we'll be good. Send me other questions on Remind. I'll be up. So I'll see you guys tomorrow. Again, 2231. You are welcome in my room. Come on down. And I will see y'all tomorrow.